welcome back to my workshop. My name is Robert. In this video I'm going to be sharpening a slitting saw. The particular saw in question was in a pretty sorry state, but it happened to be the right width for a project that I needed it for. So it's worth putting the time in to actually bring it back to some sort of usable condition. I hope you find the video interesting. Let's get on with it. I have this slitting saw that I wish to use for another project and it needs a sharpen, and if you look closely at the profile of the teeth, the primary land has been overextended, so the secondary land needs cutting back more, but the gullet's getting a little bit shallow. Now I need to cut some fairly deep grooves with this, and these gullets are going to clog up and that won't end well. So I'm going to attempt to grind the gullets out deeper and then reprofile the secondary bevel and try and get this thing sharp and usable again. So the first job is going to be to change the wheel. I'm going to put in a wheel with this sort of profile on it. So to remove the wheel from this sort of surface grinder, there's a hole in the side of the headstock here which goes through the spindle, and that enables you to hold the spindle in place whilst you remove the wheel. To get the wheel guard out of the way. Now this should just come away. This is a homemade arbor with 3 counterweights here, so this wheel has been roughly balanced, well not roughly, it's been balanced in the past, which improves the surface finish. So this wheel, we have the arbor at the back. Make sure that's clean. We put the wheel on, the front retaining washer or bush. I've got a washer there because the spindle thread doesn't go back far enough for this thickness of wheel. Pop the nut on and just give it a very light tweak. Doesn't need to be really tight. And then don't forget to take that out. Finally, before we do anything, certainly before we turn it on, put the wheel guard back in place. I want about a 50 thou radius on that, just to clean that up and give it a nice round edge so that we end up with a nice round gullet at the bottom. I don't want a sharp edge. So to set this up for the radius I want, which is 50 thou, so the height from the centre of the spindle to this surface here is 750 thou. So we take this micrometer and we set this to 750 minus the radius we want, which in this case will be 700 thou. So if we line that up on there, lock the micrometer, that now is set to 700, so I can now make sure that's all clean. Gently lower that over there, like that. Gently secure it down. Now I can loosen off the brass nut here. Just gently hold that up against the micrometer, and that should be set. It is as easy as that. So to adjust the wheel, we need the diamond to be in line with the centre, with the axis vertically here. Right, I've got you at this angle. You won't be able to see the radius forming probably, but then the dust extraction gets in the way. It's going to get very noisy, so I'll lower the sound. So I've got the dividing head on here. I'm going to use the dividing head to index around the teeth. There are 34 teeth on here. Using the dividing head will mean that it doesn't really matter where I start. I'll grind down and then I can index exactly 1/34 of a turn, because the normal technique of using a finger on the face of the teeth here won't work, because I'm going to start grinding it away. So for those who are interested in these sort of things, these are my calculations to set up the dividing head. We have 40 turns of the handle for one rotation of the spindle, and we want to do 34 teeth, which is 1 6/34 or 1 3/17, which is one turn and 3 holes of a 17 hole ring, which is 20 holes in total. I'm setting up a tooth on center height of the spindle, which means that at the top there'll be a gap in the teeth, because it's 34 teeth for a whole circle, 17 for half, or for a quarter there'll only be 8.5 teeth, so you'll be half a tooth out. Therefore, we have to advance everything by 10 holes on the plate to make sure that we transfer the tooth on the center line of the spindle to the vertical. So I want 6 degrees back, front rate, what is it, front clearance, I'm not sure which exact term it is. So one hole on a 17 tooth plate will produce a rotation of 1/40 from the 40 turns per revolution of the handle. 1/40 times 1/17, which is 0.553 degrees. So 6 degrees is 11.3 holes. So you want to take this is the tooth here, and you want to put it in this position here, so that when you grind vertically down, you end up with the correct angle here. Now we don't want to go backwards, because if we go backwards all the backlash comes into play, and we really don't want that. So what we do is we'll feed forward by 1 hole tooth pitch minus 11 or 12 holes, which ends up being 9 or 8 holes. We won't be able to get exactly 6 degrees, but the 6 degrees is not, it doesn't have to be exact, it has to be somewhere around there. So I have the cutter mounted on the arbor in the dividing head, all tightened up. I can now bring the height gauge in. I've got the magnetic chuck turned off for this. And loosen off the spindle and then rotate the spindle until the tooth is now below the height gauge. And if I just wind this in, until it just touches. That one's not too bad. Okay, so we have this tooth here on the horizontal, but on the vertical here, in the vertical plane, through the spindle, it will line up with a gap between the teeth, because there are 17 teeth on half the circle, so on a quarter there will be 8.5 teeth, so we're half a tooth out. So I need to rotate the cutter by 10 holes on the 17 plate. Take the lock off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we are. The height gauge is now midway between two teeth. So the tooth at the top is exactly on the centre position. Now, furthermore, I need to now advance by one whole tooth to keep the backlash out of the equation. One whole tooth minus 6 degrees. Here's a close-up look at the tooth profile that I've ground. You can see the leading edge is just angled back very, very slightly. This now needs the secondary bevel ground on to a good depth, which will make these teeth a lot more triangular, and then the primary bevel can be just added on or just basically polished up, because I shan't take the secondary all the way to the tip. Over to the tool and cutter grinder now to put the secondary bevel and primary bevel on the slitting saw. So I've arrived at this arrangement here by somewhat trial and error. Because the teeth are so small, having the teeth facing down, which is a fairly normal way of doing this, makes it quite difficult, because for a secondary bevel you've just got no clearance and all these teeth will get wiped out. So it ends up being this way. It's not ideal, as this is a little bit more flexible than I'd like, but it fits, and as long as we're gentle with it, it'll be okay. I've marked the first tooth so I know where I'm starting and where I'm stopping. We're set up for about 30 degrees. Bit of a closer in shot so you can see the tooth support here, which the tooth rotates up against. So this is where we got to so far. So now I'm going to set up again to get the grinding angle to about 6 degrees, and then run round and just polish up the primary land. This is the setup I've come up with. Again, the teeth are pointing upwards, so in this case we're going to be rotating the grinding wheel anti-clockwise to keep the teeth against the finger. The finger's mounted sideways because there's no way to get it in from this sort of angle, but we back out it all rotates very nicely. So the biggest problem is with the tooth immediately below. You can only feed in so far, so I've got an end stop, so won't go any further. So from this angle I'll try and show you why the end stop is needed. As you can see, this tooth just below here will go crashing straight into the grinding wheel. Make sure it rotates to push the cutter into the finger. Well, there we are. One saw rescued and very usable now. I ended the video somewhat abruptly. When I came to edit it, I just didn't have the footage, so I couldn't put it in. So I'm sorry about that, but I hope the rest of the video was interesting and useful. So until the next video, thanks for watching.